So the chain rule. We will learn a rule that will allow us to differentiate a given function without having to perform any preliminary multiplication or apply any special formula. We will let f be a function differentiable at c and let g be a function differentiable at the f of c. So then the composition of g, composite of f, is differentiable at c, and the derivative or dx of g composite of f of c is equal to g prime of f of c times the f prime of c. Please take note that another way to state the chain rule is the following. If y is differentiable at the function of u defined by y is equal to the f of u, and u is the differentiable function of x defined by u is equal to g of x, then y is differentiable function of x, and the derivative of y with respect to x is given by dy dx is equal to dy du times du dx. In other words, the derivative of a composition of functions is the derivative of the outer function evaluated at the inner function times the derivative of the inner function. Okay, so to understand this one, we will evaluate f of x is equal to 3x squared minus 2x plus 4 quantity squared. We will find the derivative of the function using the chain rule. So having our equation here, which is f prime of x is equal to y prime is equal to the dy du times du dx. So the inner function here is what's the inside. So we will encapsulate it. We will declare, we will let u be the inner function, so which is equivalent to 3x squared minus 2x plus 4. While the outer function here is the whole thing, which is 3x squared minus 2x plus 4. So since our u here is 3x squared minus 2x plus 4, so u raised to our exponent. So u squared, this is the outer function. So again, the f prime of x according to the chain rule, that's the dy du times du dx. Now, the dy du here is this one, which is the u squared. So the dy du is dy du of u squared times the du dx, which is the 3x squared minus 2x plus 4. Now, we will get the derivative of the outer function, which is the u squared. Derivative of u squared is 2u, and the derivative of 3x squared is 6x, and derivative of negative 2x is negative 2, derivative of 4 is 0. Okay, so we have the u here, and we will get it back to its original value, which is 3x squared minus 2x plus 4. So 2 times 3x squared minus 2x plus 4 times 6x minus 2. So we will expand the value, which is 36x cubed minus 12x squared minus 24x squared plus 8x plus 48x minus 16. So the final answer, we'll just combine like terms, 36x cubed minus 36x squared plus 56x minus 16. Okay, so take note of these. Our outer function, when we say the derivative of the outer function, which is the 3x squared, in this example, 3x squared minus 2x plus 4 quantity squared, we will just get the derivative, literally the outer one. We will not change anything in the inner side. So this is the equivalent for that is 2 times the quantity of 3x squared minus 2x plus 4. And if we say that we will get the derivative of the inner function, we will get the derivative of the whole thing, which is this 3x squared minus 2x plus 4. The derivative of that is 6x minus 2. So that's exactly what happened here. It's just that we used u to encapsulate the whole value of the inner function. Okay? Okay, another example. We will evaluate y is equal to sine 2x. So using the chain rule, we will differentiate the value of the function. Okay, so the sine 2x here, so the 2x is the inner function. So we will declare it, or we will let it as our u. Let u is equal to 2x. And the sine u as our outer function. So it means we'll not change anything in the value of u, or in the value of 2x. So the f prime of x according to the chain rule is dy du times du dx. So the dy du is sine u, so the d du of sine u, and the d dx of the 2x. So the derivative of sine u is cosine u, and the derivative of 2x is 2. We'll get back to the u to its original value, which is 2x. So cosine 2x times 2. So the final answer is 2 times 2 cosine 2x. So if you have noticed, again, the outer function, which is sine 2x, the derivative of the outer function is cosine 2x. Notice, we did not do anything in the 2x. So, the derivative of the outer function is cosine 2x. While notice again, in the inner function, which is the 2x, we will get the derivative of the whole thing, which is the 2x itself. So the derivative of 2x is 2, which reflects here. So the final answer is 2 cosine 2x. So remember this one. This is the generalized power rule. According to the chain rule, the derivative of f of x raised to n is equal to n times the function raised to n minus 1 times f prime of x. That's the generalized power rule. So if it is, if our function is separated, if our exponent or the power is separated by the, let's say, the bracket or parenthesis, we can apply the generalized power rule to get the derivative of the function. Okay, so example, we will get the derivative of y is equal to 3x squared plus 4x minus 5 raised to the fifth. So the outer function here is this whole thing raised to the fifth. So the derivative using the generalized power rule, so that's the exponent, which is 5, times the 3x squared plus 4x minus 5. Take note, we did not do anything inside, so we will just leave it as it is. So 3x squared plus 4x minus 5 raised to the fourth times the derivative of the inner function. So derivative of 3x squared plus 4x minus 5. So that's 6x plus 4. So this is the final answer. So the derivative of our function is 5 times the quantity of 3x squared plus 4x minus 5 raised to the fourth times the quantity of 6x plus 4.